Hello everybody, I'm Abulfaz Bazatpour, and in this video I'm going to discuss about the naming of ligands in the inner coordination sphere of complexes. As you know, for a normal complex, we must have an inner or primary coordination sphere, and if we have an ion complex, we will have a secondary or outer coordination sphere. At the time of nomenclature of complex, we first specify these coordination spaces. Y is always dependent on the final charge of the ion complex and includes anions or cations. And we will use common names of Y. For example, chlorine with negative charge is called chloride, or SO4 to minus is called sulfate, or Na plus is called sodium. It's a common name of sodium. But to nomenclature of X and L, we need to discuss and practice together more. Anionic ligands are usually represented by caps lock X, same as the fluoride, hydroxide, hydride, nitrate, and natural ligands are usually represented by caps lock L, same as water, amine, carbonyl. Nomenclature of X. Before starting to nomenclature of the ligands, it is necessary to mention that in all the examples presented for easier understanding, coordinating atoms of ligands are shown in blue color. Then for anionic ligands that usually end with IDE, the term IDE will be replaced with O in the naming time. For examples, fluoride, fluoro, chloride, chloro, oxide, oxo, sulfide, sulfo or thio, selenide, seleno, methoxide, methoxo, cyanide, cyano, hydroxide, hydroxo. For anionic ligands that usually end with ATE, the term ATE will be replaced with ATO in the naming time. For examples, carbonate, carboneto, nitrate, nitrato, cyanate, cyaneto, thiocyanate, thiocyaneto. If sulfur replaces oxygen in cyanate, we will use the prefix thio at the beginning of the name. Cyanate, thiocyanate. So, when an unbidentate ligand is coordinated to the metal from the other side, we will use ISO prefix at the beginning of the ligand name, same as isothiocyaneto. In the isothiocyaneto, the SCN is coordinated to the metal with nitrogen atom. In the following, acetate, acetato, sulfate, sulfato, thiosulfate, thiosulfato, As you can see, one sulfur atom replaces oxygen in sulfate. Then we will use the prefix "thio" at the beginning of the sulfate, same as thiosulfate or thiosulfato. In the following, I would like to introduce a number of anionic and natural ligands that you see many times in the naming of coordination complexes. Please pay attention to their naming method. NH3 amine, NH2 minus amido, NH2 minus imido, N3 minus nitrido, N3 minus azido, NO3 minus nitrato, NO2 minus nitro, ONO minus nitrito, NO plus nitrosyl, N2 dinitrogen, and trimethylamine, dimethylamine, and methylamine. And in the following, P3 minus, phosphido, and phosphine, trimethylphosphine, and triphenylphosphine. And for H2O, aqua, OH minus, hydroxo, H minus, it is not hydro, it is hydrido, D minus, dotrido, and phenyl with abbreviation PH, methyl with abbreviation ME, and ethyl with abbreviation ET, and CO carbonyl and CS thiocarbonyl, and pyridine with abbreviation PY. In addition to monodentate ligands, there are many multidentate ligands that are observed in many coordination complexes with the chelate effect. In the following, I will introduce the most important bidentate ligands. Ethylene diamine with abbreviation EN. 1,3-diaminopropane with abbreviation PN. Oxalato with abbreviation OX. 2,2-prime-bipyridine with abbreviation BPY, and 1,10-phenanthroline with abbreviation PHEN. Orthophenylene bis dimethylarsine with abbreviation DRs. 1,2-bis diphenylphosphinoethane with abbreviation DPPE, and glycinato with abbreviation of GLY. 8-hydroxyquinolinato with abbreviation 8HQ, and acetyl acetonato with abbreviation of ACAC. And the tridentate ligands as diethylene triamine with abbreviation DN, 1, 2, 3 triaminopropane with abbreviation TAP, and terpridine with abbreviation terp. In the following, we have tetradentate ligand names as the tris-2-aminoethylamine with abbreviation TREN, nitrilo triacetato with abbreviation NTA, triethylene tetraamine with abbreviation 3N, porphyrin with abbreviation POR, and phthalocyanine with abbreviation PC. Here I want to show 3 examples of penta and hexadentate ligands as tetraethylene pentaamine with abbreviation tetraen, and ethylene diamine triacetato with abbreviation ED3A, and the hexadentate ligands ethylene diamine tetraacetato with abbreviation of EDTA. By the type and name of each of the given ligands in coordination sphere of complexes, Br-. It is X type of ligands, and the Br- is the bromide. Then I change it to bromo. In the next ligand, it is basically an amine compound with ethyl and methyl groups. Then I can name it ethyl methylamine, and it is the L type of ligands. And in the other one, O2 2- is peroxide anion. Then I can name it peroxo. Peroxo is the X type of ligands. And in the other one, dimethyl amido. The amido ligand is NH2-. Then here I have to replace the 2 hydrogens with 2 methyl groups. Yes. Methyl phenylphosphine will be pH MEPH. Methyl phenylphosphine. And finally, thiosulfito. Yes, we know that the sulfito is SO3 2-. Therefore, we will replace 1 oxygen of sulfito with sulfur atom, S2O2 2-. Yes, stay with me and watch my new video to learn about the nomenclature rules of coordination complexes. Bye bye.